Hi, in this video, I'm going to discuss about an important topic, a topic that a number of people have asked me. So they asked me this question that how to become a data scientist, and they are working in IT departments, either as a developer or tester or a support engineer. So I thought of making a video wherein I'll discuss the similarity between these two roles. And when we say we want to become a data scientist and we are working as a developer, they mean they want to switch career. But it appears to me that there are a lot of similarities between these two roles, and one need not switch his career. Rather, one can learn data science skills and applies to his own role, and really it will be really enriching. All right, so I'll discuss the different aspects of being a data science and how is it different from somebody in software development. All right, so what is the role of a developer in IT industry? Okay, so one would be doing application development. So application development could be a web application development in the internet or intranet, or a mobile application development, or enterprise software development. It could be as simple as extracting data from your databases and providing it to business, writing a lot of SQL queries or PL SQL queries, right? It could be business intelligence and reporting. So it could be using Tableau or some sort of Microsoft BI, some sort of business intelligence, extraction of data, providing data in some format, doing data quality checks, and maybe doing basic reporting like counting number of certain events and stuff like that. So that kind of work, or maybe customization. There is already an enterprise software in place. You are customizing the software to make sure that it is ready for use by the business, right? So these are essentially the roles of developer. There are other roles, of course. I am not aware of all the roles in the developer community or in the IT software development community, but I have worked with IT departments of some companies, and I used to be a data. I used to be mostly into business intelligence, and what I know is that we used to write PL/SQL packages which extracts data from databases, and then we used to do reporting of data in certain format for a very big company. We used to work for General Electric. All right. So let me talk about what a data scientist does. Okay, so what kind of work he does. Okay, so he does statistical modeling. He uses machine learning, optimization techniques, and does a lot of analysis on data. He also finds out or provides insights by making use of the analysis he is doing to the business. So these are roles. Now, the word data scientist or somebody who do data science, who uh, you know considered to be an expert on data science, is not very clearly defined. Okay, so this is a disclaimer I'm giving at the start of this presentation, that these are terms coined outside the academic world. Okay, so if you go to an university, you won't find a department called data science department. Some of these universities have started, of course, for their own benefit, but these are not traditional university departments like statistics or like economics or computer science. These are not traditional academic areas. These terms have been coined by the industry itself. Okay, so pretty much a industry term. Okay, like, all right, so just to these are jargons, I'm sure, and somebody who is not who is hearing these terms for the first time would wonder that what these jargons are or what these terms are. Well, I'll talk about it more about it in the coming slides. Okay, so all I can say is that all these jargon, statistical modeling, machine learning, optimization, these jargons have something to do with one particular thing which connects developer to data scientist, that is data, right? So we learned about different aspects of roles or different roles by the developer community. So they do application development, they do extraction, data for extraction, business intelligence. So they also play with one particular thing, that is data, right? It could be customer data in the banking and financial industry or e-commerce industry or payment industry and so on. It could be healthcare data, data about patients, doctors in the healthcare industry. Um, it could be clients data. Okay, somebody working for a B2B business segment. So all right. So one thing that connects developer with data scientist is data. Okay, so data connects both data scientist and developer community. Okay, so ideally what happens is that most of the analysis part is done by the data scientist, and extraction of data, application or development of softwares, applications, these are done by the developer. However, there is a lot of work which cannot be done by simple analysts who knows a bit of statistics, a bit of business, and by using statistics and the business knowledge, write a report about certain problems in the business. Okay, these people cannot do certain activities which requires a lot of software coding. Okay, hence this role, data science, combines developer and analysis role, application development and analysis role, and by making use of data. Okay, so as a data scientist, one would be doing 60-70% of uh, a developer role and 30-40% of analysis uh, work. Okay, and it could differ. It depends on the role, it depends on the team you're working with, depends on the industry you're working with, and so on. So the uh, the answers to my friend's question that okay, we want to change our career to data science, is a wrong question, because you are not changing, because there is an overlap between what a data scientist does and what a developer does. 60-70% of the work is pretty, I wouldn't say same, but similar. Okay, there is just a variation of the same work. Okay, all right. So now we'll see how one can combine the skills of a developer and skills of a data scientist. Okay, so where is the gap? Okay, so where is the gap? There is a gap in the employment community. Most analysts or predictive modelers, statistician, these were the terms used to be used 10 years ago, but now people are using this term data science. So don't worry about how they're different, but uh, there is some sort of an overlap in the roles taken by these people. All right, so statisticians have been in the forefront of data analysis for decades. Okay, and these people lack programming skills. They are good at statistical programming, but not good at general purpose programming. Like they are not familiar, most of them, not everybody, familiar with Java, .NET, or it could be C or C++ and so on, right? Not everybody. I know there are statisticians who know more C++ than application developer, uh, an average application developer. Okay, so it's not that everybody doesn't know programming, but a lot of them don't know. Most of them, I would say, don't know good general purpose programming. On the other hand, developers lack math stat skills, machine learning skills. Um, Developers come from computer science engineering background, but over a period of time, they don't use what they have learned in college or university, because for development of softwares or for extraction of data from warehouses, you don't need any maths or stats, or for that matter computer algorithms or logic, uh, although it is taught in colleges, right? People have learned about a lot of algorithms in the computer science uh, courses, algorithm, data structure, and so on. So developers, not everybody though, lacks these skills, right? So one who knows both is high in demand. Somebody who can write really good program, really good. You can do programming in Java, .NET, C++, and so on. And he also knows machine learning, or he also knows a bit about stats. Is is highly is in high demand. That skill, the combination of both, is in high in demand in the employment market everywhere in the world, in Asia, in Europe, in particular in US. Is very, it's a very niche skill. I mean, somebody with both the skills is very hard to find. Okay, so somebody who is into application development or software development. So a developer, if he wants to become a data scientist, or he wants to learn data science and use data science skills in his own role, what are the things he has to learn? So he has to learn the basic statistics and real algebra to begin with. Okay, so basic statistic could be as simple as mean, median, mode. So how to locate data, how to visualize data, how to summarize data. These are the things he has to learn. Real algebra could be matrix, how to put data into matrix, how to do matrix um, multiplication, transpose, adding, subtracting matrices, and so on. And there are a lot of algorithms uh, which also are important and one should learn. Okay, start with statistics, basic mathematics, and then move on to more rigorous learning. Okay, in machine learning or in statistical community, there are basically two types of um, algorithms. One is supervised learning algorithms, and the other one is the unsupervised. We'll talk about these two algorithms in the next slide. Okay, so we can divide most of these algorithms into these two categories: supervised and unsupervised learning algorithms. The difference is very simple. The difference is just that in unsupervised, in supervised, you have a label to the data. That means you know some of these outcomes uh, previously, and that's how you know the pattern. Whereas in unsupervised, it's totally there is no labeling of data. So we'll learn more about it later. Okay. So some of these supervised, unsupervised algorithms could be regression, classification. So all these two are supervised learning algorithms, and there is something called clustering, which is both supervised as well as unsupervised learning algorithm. Forecasting, knowing about futures. So forecasting future. There are different types of forecasting, that also is important. Optimization, that is what is the best way to uh, you know do something. So that's optimization. Simulation is nothing but creating a scenario which is totally artificial or created. It's a not a real scenario. It's a semi-real scenario, I would say, or totally an unrealistic, totally a scenario which is not real, but it is very similar to the real scenario, where you can test your system or test your algorithm just to see how it works. So that's known as the simulations. All right. So let's learn a bit about this, things, these jargons that we have discussed. These are simple, but if you want to learn in detail, you have to go through a long theory before you can start using this work. All right, so let's learn about what is regression. So regression is very something that is used in many fields, not just in the field of computer science or machine learning. It's used in economics, it's used in statistics, it's used in psychometry, ecology, biology, and so on. So what happens is that many times you will get data like this, right? Let's say there are two data points, y and x, and they are some way they are related to each other. Okay, so given this data, you like to know that if we know x, can we know y? Okay, so how do we do it? You already know the value, the way x and y are related. Okay, you have been given data, right? Let's say when x is 5, y is 10. When x is 6, y is 12, or maybe 13. When x is again 5, then y takes a value of 9. When x is let's say, okay, let's say it's 4, 3 it's 6. Okay, but you don't know how they're related. Okay, you would like to know through a function, okay, fx, but you do not know how to. So what you do is that you just plot these variables in a two-dimensional plane, x and y, and you try to fit a line which passes through the data points. Now that line equation is nothing but a regression line which relates these two variables y and x. So y could be y equal to, let's say, 4 plus x. Okay, and every time now you find this from this regression line. Okay, now how you find this line is something that will that for that you need to learn the theory, but that's what it is. That's what it is. Okay, so y equal to 4 plus x, and every time you know the value of x, you can find the value of y. So it's so how do you find this regression line? You can find this by ensuring that the line passes the middle of these data points. Okay, so the distance between these points and the line is minimum, and that you can find out by using some sort of an algorithm which is provided by most softwares, okay, and mathematics packages by programming languages like Java, Python, and so on. Okay, so that's called and it comes in the supervised learning algorithms because the value of y is known, and y is known as response variable. Okay, in this case, so the left hand variable is always 1. There is only one left hand variable in this equation, and this is known as the target variable, or also known as the response variable. All right, there could be several other variable right hand side variables, or known as the explanatory variables, or some people call it features also. Okay, so y could be, let's say, a plus b1 x1 b2 x2. So there could be any number of x in the right hand side, so any number of predictors or explanatory variables in the right hand side. Okay, and these estimates like 4 in this case and 1, these are called estimates, a b1 b2 and so on. These are called estimates which you find from the while fitting this regression line. Alright, so that's called regression, and there's something called classification. So there will be cases where you want to classify customer into groups. Okay, and the groups are given to you, like, okay, somebody is a good customer and bad. If it is a good, then it's labeled as 1, and there are different features like customer income, okay, income, his amount purchased, and so on is there. 0 1 0 0. So his customer is good, then he is labeled as 1. If he is bad, he is labeled as 0, right? and his corresponding income amount purchased is given to us. So the question is, can we find that a customer is good or bad in future given his income? Only if we can find some sort of a relationship. So that is given in the classification. So for a given data, how do you classify? How do you, let's say, how do you classify this? Okay. So you classify with the same regression line, but there is some sort of difference in the algorithm in the regression and classifications. All right. And this is also supervised learning algorithm because you also have the response variable in this. That means in the historical data you have this classification of data. Sometimes this won't be very clear. Sometimes you only know income and amount purchased, and you don't have this data with you. Okay, this is not given. In that case, there will be many customers, and you just have to uh, classify them. Classify which are good customers, who are bad customers. Okay, without knowing previously that who are good or who are bad. Okay, so in a clustering you won't have equations like this: y equal to a plus b1 x1 b2 x2. It's not very simple. You can't learn it in 10-15 minutes. You just have to go formally. So these are easy. Okay, you just, it's as we see, these are simply playing with your data. Okay, so algorithms are playing with data. Optimization could be finding out the best value of a, best value of b1 b2. Simulation could be finding out scenarios what x1 x2 could take. So these are called optimization simulations and so on. Okay, so it's easy to learn the basics, but in order to learn in depth you have to spend a good lot of time. All right, and don't worry if you don't understand everything clearly in this particular video. You can learn a lot of it on our YouTube channel. We have uploaded plenty of videos about regression, classification, simulation, optimization, and you can find this video in our playlist. So all right, so how to start learning? Okay, so I guess you need 100 hours of rigorous learning to get a basic idea. Just to be clear with the basics, you need 100 hours of rigorous learning, but you would need a lifelong learning to master something, so that's different, right? So if you're not good with math, so brush up your math skill on Khan Academy. So that's a very popular YouTube channel, and also they have the web platform where videos have been categorized into. So all you need to know is learn bit of real algebra, calculus. uh, in real algebra learn matrices and matrix operations, vectors, and so on. Learn bit about coordinate geometry. Okay, how to find Euclidean distance between two points. If you are lazy, if you don't want to go through all the videos on Khan Academy, there is a playlist on our channel where you can go through the basic mathematics required for learning data science. There are 4-5 videos. It will take half an hour to 1 hour to just brush up your math knowledge. And then you can learn the basics of R, Python, and SAS. You can learn all these things on our channel. You can also subscribe to some of the very good channels on R and Python on YouTube, and you can learn on them. You can also learn R and Python on Data Camp. It's a very good site. You can learn over there. All right, or maybe you can learn from uh, the R blogger if you want to learn R. For Python, you can go to Python website, and there are plenty of things you can learn. But for Python for data science is something that is slightly different from Python from programming. So for Python for data science, subscribe to a channel called CentDex on YouTube, and there are plenty of good materials on Python programming for data science on that channel, so you can learn from that. And then you can learn the basics, the theory behind regression, classification, clustering, forecasting, optimization, simulation, and so on. So how do you learn this? I'll talk about it. If you're not sure about it, just um, search these terms on Google or on YouTube. You'll find plenty of materials. And then build a first model. If you search how to build a machine learning model, a predictive model, there are plenty of blogs which will tell you the step by step. You can also find a blog post on our website, which is in the description section of this video, where we have talked about the step by step model building uh, using R, Python, and SAS. You can also find case studies on our channel in which we have followed the different steps of building a model. Now take real world examples. You can take real world examples from your own area, the area in which you're working. For example, if you're working in telecom, take a case from telecom industry. If you're working in finance, take a case from financial service industry, and then build a model, and you can apply whatever you have learned in theory. All right. So what are the places? Where are the places you can learn all this stuff? Okay, if you have time and money and you want formal education, you can go for training. A lot of training institutes are there in US, in Europe, in India, in Singapore. You can go for classroom training. You can go for online training, um, and you can also go for master's program, 1 year or 2 year master's program if you have time and money. That's also good. Okay, that's a formal way of learning, and then by the time you have finished your program, you would have mastered a lot of things. But a lot of people can't afford that, right? So you can go for MOCs on Coursera, EDX, and you can also do a lot of courses on Udemy. But the problem with these courses are these are theoretical. Some people will lose patience. Okay, but I would recommend to do a couple of courses on Coursera and EDX if you have time and patience. All right, that's also important. But nowadays, I think Coursera is charging money, so that's also costly. For certification, you actually don't need certification in order to learn something, so you need not pay money. You can learn it for free. If you want to learn it for free and learn it at a pace that you want, then you can watch a lot of YouTube videos. We have our own channel where we have more than 300 videos on data science, predictive modeling, SAS, R, Python. You can explore, you can go through these videos, and I think that's sufficient for somebody to understand the basics of data science. You can also subscribe to this channel called Sendex, where you can learn plenty of stuff on data science using Python. Okay. You can also hire a personal tutor. There are a lot of people who are working as freelancer or personal tutor. You can certainly contact us for this. So analytics university at gmail.com if you want a personal tutor who will guide you through. Somebody who was working in industry and you want his guidance in doing projects or teaching him theory of uh, different data science algorithms, you can contact us. You can also find help from different people on Quora, on Stack Overflow. A lot of passion. It's a good passionate community. It's free, totally free, and you can get help from them. All right. You can do projects. Without projects, you won't learn anything. So it's important to do projects, real world projects. You can find a lot of real world projects in GitHub, but it's highly technical. Most of the projects on GitHub are highly technical. So somebody who's not good at technical things, probably you will find it intimidating. But I think there are a lot of people are there to help you out on that. So explore these communities on GitHub. Ask questions on Quora, read question answers. A lot of people have said links on Quora about how to build real world projects. Kaggle is the best platform, I would say. There are a lot of simple projects you can do on Kaggle and submit your answers and see your results by yourself. You can take part in the competitions, data science competitions. And if you don't do well, uh, don't worry about it, because uh, I mean, a lot of people say that if you do well on Kaggle, only then you are a good data science. That's not true. The way Kaggle judge your project is based on the some sort of a score, and is a very simple difference in simple very small score could bring your rank in the Kaggle competition to very low. It can give you a very low rank based on a very small difference, and that difference doesn't matter much in the real world. Okay, so don't worry about that. All that matters is just learn, have fun by some participating in the competition on Kaggle. Analytics Bida is a brilliant blog. It's a passionate community. Learn a lot from them. Read a lot on the blog, and they give a lot of advices. Most of the advices they give are correct. Sometimes you will feel that you don't know anything. A lot of people know a lot of things. Don't worry about it. That's not true. Not everybody knows every aspect of data science. Um, I have been spending a lot of time on learning things, and I also feel bad that I don't know much. In fact, I know a very little about data science, and I feel sometimes nervous while talking about it. But that's not the problem. The reason why you should not feel uh, intimidated, or you should not feel bad about the fact that you don't know much about these algorithms, is that these algorithms have been taken from different fields, from statistics, from mathematics, from machine learning, from psychometry, from operation research, from I don't know, even many other areas, econometrics. It's practically impossible for somebody to master all these fields. Practically impossible. If you're good at statistics, you probably may not good with operation research, right? So you may not be good with optimizations. If you're good with optimization, you may not be good with this machine learning skills, right? So it's practically impossible to be good at every single thing. Okay, so you just have to know the applications of it, or understand bit of theory. You don't have to be good at every single thing. Nobody is. In fact, if you go to a statistic professor, he will say he only specializes in one area of statistics, right? He could be good at you know um, the inferential statistic or a Bayesian statistic. He may not be good at every areas of statistics. If you ask an econometrician, he may be good at time series forecasting. Okay, he may not be very good at everything, right? So it's very difficult. Okay, so not bother you. So what are the prospects? So what are the things you can do after learning data science or these algorithms I've talked about? You can build recommendation engines, right? So whenever you purchase something on Amazon, it recommends you, right? Or whenever you watch a movie on Netflix, it recommends you movies, right? So recommendation engine is very common nowadays in almost every business that is online. Recommendation is engine is very important. In financial service, if you have taken one loan, they will recommend you to take another loan based on your some sort of a behavior. Okay, so it's an important skill to have. Okay, you can build recommendation engine by learning the supervised learning algorithms. Okay, and it's not very difficult to do that. Okay, you can build a simple recommendation engine by learning regression, classification, and so on. You can predict price in many places for e-commerce companies like um, online booking, finding out the airfare, finding out price of interest rate charged by different financial service companies. So price prediction is one thing that you can do. You can automate a lot of things. You can automate loan approval by financial service company. You can automate loan, um, a lot of activities where decision has to be taken without even taking a human decision. You can automate all these things. You can find churn prediction in telecom industry, in finance industry, in e-commerce. You can find the churn prediction. You can do a lot of financial risk modeling. Okay, finance is a very broad area, but risk modeling in particular uses a lot of quantitative things, data mining skills, data mining and statistical modeling. So you can work on credit risk, which finds out whether somebody is going to default on loan. And you can also use work on forecasting, so forecasting loss, revenue in a bank, and so on. Even if you're not working on building these models, you can actually understand this and work in the periphery. Maybe you can implement these models. So a lot of IT people implement these risk models in their work, and they're highly paid, by the way. So what's important is apply your skills in the same role. You don't have to be in a data science team to be able to implement or use your skills. If you're working as a developer, learn how you can use data science skills in the same role that you're working. So and there are many areas in which data science roles can be used in software development, in um, IT support, and so on. There are some of the myths actually, okay, about learning data science. Some people say that only people with good with maths can learn. Yes, that's easy. If you know maths, that's easy. But you don't have to know maths in order to learn data science skills. The reason is because um, you don't have to learn theory all the time. You don't have to be really good at theory. If you know how to apply these algorithms, that's good. Experience is a must in the field. That's not true, because this field is at a very nascent stage. And secondly, experience about what? If you have experience in domain, you are a chartered accountant, you know a lot of finance. That's very good skill to have in order to be a data scientist. If you are a developer who has got very good programming skill, that's a really good experience for this fields. So it's not totally different. As I said, 60-70% of the skills are overlap, right, with the skills of a developer. So you don't need a prior experience in this particular field to be able to start your career. Late career shift is not possible. This is 100% wrong. I have helped at least 10 people with over 10 plus year experience to completely switch career from other fields to data science or analytics. Okay, so it's totally not uh, a relevant question that late career shift is not possible. The reason why it is because there's just not enough people in this area, and it's a totally new area. Okay, and this is area which requires domain skills, and for domain skill only experienced people are good fit. And this is also an area which require architects. An architect must be good at development and must be having substantial development experience. So let um, and there are areas where the management experience also is important. A lot of people with good management experience but who have lost touch with technology also fear that they will not be good fit in this area. That's not true, because management experience is also important. So if you understand what happens in this area, learn the basics of it, you can be a manager in this area, if not in highly technical area, but yeah, in maybe areas where you don't have to sit and write code, but you have to manage people who actually do all these stuff. Some people say you have to have a science and technology area. It's not true all the time. People with a degree in economics, degree in commerce, somebody who is good with school maths, he knows school maths, and hasn't continued college or university degree is good enough to learn data science. So you need not have science and technology degree, although an advanced degree in science and technology helps a lot. The most important myth is data science is just new technology. There's technology called Hadoop who got a lot of attention and is losing attention nowadays. So people say, okay, this is just a new technology. This is new hype. So not true. Um, Although we're calling data science nowadays, the use of math, stats, operation research in business has been there since a century ago. There's a profession called actuary. They have been using this in the insurance industry for over 100 years. People in the oil and gas industry have been using data mining skills for a long time. People in finance have been using what is known as a quantitative finance for a very long time, right? For investment purpose, for finding out who is going to default on the loans, which counterparty is going to default, what is going to be the loss in the next quarter. So it's not nothing to do with technology. So technology might change, right? But these original mathematical or theoretical ideas are going to remain same, because theory don't normally change so soon. We have been using calculus for from 1700 century, right? Calculus. Ever since Newton came up with calculus, we have been using it, and it hasn't changed much, right? Hence, unlike technology, data science skills are going to remain pretty much the same over next few decades. Okay, only the technology aspect will go to change. We are now using Python. We may be using some other technology, some other programming skills, but regression, classification, optimization, clustering, there won't be much change. There will be only few changes. Okay, explore new areas. Okay, there are areas where this is highly important, but I have worked in this area, by the way, and I see that not many people are using this. For example, a lot of people are working in ERP system like SAP, like Oracle apps or PeopleSoft, right? People don't use data science techniques, but these are areas where data scientists are not there. So if you're working as a developer in this area, you can actually start your own team, data science team, and have this first mover advantage. Like if you start using or start talking about data science, use of data science in these areas, you will get a lot of attention from your managers or senior management who will see values in this area, right? So if you're working in ERP, CRM, or enterprise, any other enterprise software, start using your data for operation, for supply chain, for order management, inventory, for accounting related things, and use your data science skills in this area, and show it to a manager, show it to people in the management, the value that you're creating out of it, so that you can really be the forefront of the changes happening in these areas. For somebody who are working in data quality, reporting, IT support, you can also use your skills in that. You can use for automate data quality checks, for report dynamically in order to find out IT issues, support issues automatically. You can automate certain things. Okay, all right. You can also explore domains or business areas where um, data science is not getting any attention, or it's not getting any, or there is no data science at all in these areas. I know there are a lot of areas where it's unexplored or untapped. So explore these domains um, and take the advantage of it. Okay, by being the first mover. Automation. Okay, so everybody's talking about automation nowadays, right? Every CEO of IT company is talking about automation. Okay, automation is a good thing. It automates a lot of things. It's a bad thing because it takes away jobs, human jobs, right? So a friend of mine was saying that in the age of automation, the important skill to have is to know how to automate. If you know how to automate, that's the best skill to have, because that is one skill everybody is looking out for, right? Data science is at the forefront of automation, right? Whether it's recommendation, now previously it used to be somebody who will manually see who is the best, which product is going to be selected by a particular customer. Now it is automated. It is done by machines or done by some sort of an algorithm or some sort of a code written in the background. So data science skills are very important to automate something. Um, so this is an important skill. So that's the idea. Almost all IT service companies like Infosys, TCS, IBM are talking about automations. Okay, so how are they, achieving this? They're hiring people from with skills who can automate. Okay, and so these people are going to be in demand. Short term, I'm sure there are a lot of things which cannot be automated, but a lot of value addition which is going to happen in almost every area. Digitalization, everybody's talking about the digitalization. Okay, digitalization in some way has changed the way things were done. For example, e-commerce wasn't very prominent a decade ago, right? Not everybody used to purchase online, but now that has changed. Smartphones, use of internet has reached out to even in the remotest part of developing countries, let alone the developed countries where it is has been there for some time. All right. So how is data science important in this case? Well, digitalization uses lot of automatic way of doing things. Okay, um, and that requires lot of personalization, lot of behavioral decision making. Okay, whether it could be your smartphone telling you that you have not uh, taken your lunch or dinner, or your smartphone providing you the data for how the weather is going to be tomorrow and how you should plan your activities for tomorrow. Everything is data driven. Everything is data driven. Okay, and the only important thing uh, that connects developer and data scientist, as I said in the beginning, is data, right? So digitalization is bringing in more data. Internet, smartphones are giving us terabyte of data. Okay, so there is going to be more demand for developers, data scientists. Okay, and somebody who is a developer and is a data scientist is going to be a rock star. He's going to be writing his own paycheck, right? Because he knows both areas. I don't know one area, by the way. I don't know how to uh, you know develop an application, a software application from scratch. All right. So there is a fear of losing jobs. Many people are fearing that they're going to lose jobs because of automation. But I see this is an opportunity actually. Okay, if you can identify areas where a lot of things can be automated through skills, through algorithms, then you will be uh, you will be adding a lot of values actually, and not just values. You will be in high demand. So it's an opportunity, I would say. So what are the advantage? What are the advantage? You have, yeah, I said in the beginning that you need 100 hours of practice to learn these things, and could be even more. Okay, 200 hours, 300 hours, could be even a lifetime learning. Okay. So what are the advantages of learning these skills? One of the things that you might have heard from people, and this is true. In fact, you can check it in internet, that mathematics skills have always been respected and rewarded. So somebody with good math skills or algorithm skills have always been highly paid. They have been rewarded, and not just in recent times. Of course, in recent times, more and more people are attracted to this field. But even my class teacher used to say that somebody, so when he taught optimization, he used to tell us that people from operation research are like the highest paid in the manufacturing industry. Okay. When I learned finance, okay, when I was in a finance class, my finance teacher used to tell me that people from quantitative finance area, quants are the high some of the highest paid people in the finance departments. Okay. uh, uh, when I used to take classes in insurance, people used to tell me that actuaries are highly paid uh, in the industry. Okay. So if you look at the pays of actuaries, they have been using mathematics, statistics for decades now. So they have been highly paid. So anyone with good math skills, algorithm skills are highly paid. It's intellectually challenging, and hence it's very interesting because you will be learning a lot of things. You'll be learning from blogs, from books. So you'll be in touch with academics, unlike in many software jobs where you will be losing touch with academic areas, right? So you'll be learning a lot of things from research papers, from blogs, from people, from conferences. So you'll be in touch with academics. You'll be closer to business because you will be solving business problems, right? So if in future you want to move to a business role, it is easier from a data scientist moving to a business role than a developer moving to a business role, because data scientists will be more involved in solving business problems, so they would have learned a lot of business in that particular role, right? So you'll be closer to business. um, you will be a domain expert, right? If you're working as a quant in finance, you are a domain expert in finance. If you are working as a data scientist in e-commerce, you are a domain expert in e-commerce. So your expertise will be highly valued. Okay. But you can't be a domain expert by just working as a developer. I haven't seen many people. There are people, but not many who are become a domain expert just by working, because most of the time will be writing codes. So that's one disadvantage of being a developer, I would say. Because, and you can't be a developer all your life. uh, After 5, 10, 15 years, people lose interest in that area because it involves a lot of hard work, which at later age not many people can afford to do. So it's important to be a domain expert, and by being a data scientist, you will be a developer at the same time. You will be a domain expert. So that's an advantage. Excitement of problem solving, that nothing can be better than this. When you solve problems on a daily basis, that's very exciting, and you won't burn out. Okay, you'll start loving your corporate life. Remember one thing: unlike technology, math, stats, machine learning won't change so soon. It's going to be there for a while. Unlike in technology, there is always a fear that, okay, like people used to learn mainframe, right? And mainframe is not a very forefront of technology nowadays. Same happened with Java. When Java came, a lot of people switched to Java, and then that skill is because a lot of new technology came and it became our old technology. So technology changing very fast, and it takes a lot of time to master something. And then some people feel that, okay, we learn now, we have spent a lot of time. What if this will become outdated? Unlike technology, mathematics don't get outdated. We have been using calculus from 16 1700 century, okay, ever since Newton came up with this idea, right? Similarly, techniques like regression, classification, these are things which have been invented, or the theory has been invented in the early 19th century or late 1800th century. Okay, so your skills is not going to be outdated soon. Okay, so it's a lifetime learning. Okay, So be sure that all these things are going to be relevant even in the next decade, in the next couple of decades, I would say. So it's interesting, and you have every reason to be interested in this area and to learn. You may not switch your career. That's a wrong perception. You don't have to switch. So if you learn certain things, uh, certain algorithms, you will be more productive in your own area. You will be rewarded for that. That's for sure. All right. Thanks for this watching this video, and enjoy learning data science. And please let us know your experience. If you have been inspired by this video and have started learning, please share your experience. This is our email ID, and please visit our website. We have plenty of things on our website. You can learn a lot from our website. We have a lot of materials. Please subscribe to our channel. You will get a lot of free content on our YouTube channel, and we are uploading a lot of videos on algorithms, on statistical programming, on machine learning on our YouTube channel. So please subscribe to our channel, and please share um, you know the links to our channel and links to our website with your friends who are also interested in learning these things. And please contact us if you want any guidance related to learning data science or analytics, starting your career, or for yourself with your friends or family members. Just let us know. Thank you so much. Thanks for all the support.